Hello, Tyler Gorn here with another Redstone Showcase video. Today I wanted to talk about a concept for a charcoal farm that I came up with probably over a year ago now at this point. And I was reminded of it recently because it came up in my Chores Around the Server series. So I wanted to kind of revisit this and get it maybe tidied up, add some more features to make it more robust and generally applicable, just in case it was of interest to anyone. The idea here basically would be that we've got, any sort of tree farm of a certain rate. There's so many different designs of that, of course, out there. So you can basically just use whatever tree farm you have and use the modular design of this system to add a charcoal generating module onto your pre-existing tree farm and, just kind of get some fuel if you need it for various projects. So first, I did want to start with some basics. So most people that have found my channel probably already know this, but just in case, furnaces operate once every 10 seconds exactly. So that's 100 ticks, 200 game ticks. So that's important later. We'll come back to that because it changes how we do things. This is also very basic, but we take hoppers. If we want to automate anything with a furnace, raw material goes in through the top, fuel goes in through the side, and then output comes out the bottom. So that's going to be the basis of any furnace array that we're going to do. It's going to look something like this. So usually a furnace array that's general purpose, what you would do is load mine carts, and then you could imagine this goes off in this direction. You've got like this sort of thing, and your raw material goes over the top, and then you've got hoppers over the sides here that, a chest mine cart or something like that goes over the top and distributes fuel. So that's great for general use. In this case, our output is charcoal, which can be used as the fuel that we're doing. So why bother with a separate circuit for refueling when each unit itself can run on its own? So that's the basic idea here. Hopper goes into a dropper that then sends the fuel up to this fuel input hopper, provided that there's enough room. So, if this were completely full, or, mostly full or whatever, then we could basically send in one here every chance we get. So that's the basic idea of our charcoal farm here. And the way that we would integrate it with a tree farm, which is represented by this really cool custom tree that I spent hours working on. And so we can turn on our tree farm, and then the items are in a water stream. They simply just cascade over the charcoal farm and into log storage. So if we want to turn this on, we're already getting our product here. If we turn it off, it's just going where it was going to go anyways. And the benefit of this is that any surplus, and I'll talk about rates and everything in the different modules and how we can pick the right one. There's going to be a little bit of surplus, and it's just going to go where it was going to go anyways. So it's kind of part of the elegance of this design. All right, before we move on to the full design over there, I did want to define a term that I find myself using, as well as describe a couple of issues that I had to solve. So our system could look something even as simple as this: hopper going straight into the furnace, fuel up through here, and then occasionally this gets pulsed when we need to replenish fuel. The problem with that is twofold. So first of all, when we first load up the machine, when we first turn it on, there's our tree farm, one of the best designs out there. Our items have to fill up each hopper and the furnace below before they can even move on to the next hopper. So this is a thing you may hear me say from time to time: waterfall allocation. That might be conflating a couple of different fields. I'm not quite sure, but it makes sense in this context in my mind. So essentially, we have to complete this process before we can move on to here, before we can move on to the next one, and so forth. So even if I tick warp this, you can see this takes a while. It takes quite a while. Now, the other problem is what happens when we turn this off? Well, we now have 6 stacks of logs that need to smelt before we fully stop our operation. That's not a huge deal. You can just walk away and unload the area, but it didn't make sense to me to have a system like this. So yeah, so moving on, I guess the way that I solve that is only letting in one log at a time. So I mentioned earlier that the 200 game tick clock that furnaces do their operations on. So we've got a kind of a slightly modified Etho hopper clock here. There's 13 items in here, and if you do the math on that, it's like time in seconds equals x times 0.8 minus 6. The x times 0.8 in parentheses, I'll put this in the description, kind of helps me out. So in that case, what we get is, well, we basically determine that there's not a number of items that can get exactly 10 seconds. 13 items, that gives us, I want to say it was 9.8, and the repeater here on 2 game ticks, that gets us that 0.2 seconds of extra time. So this is exactly 200 game ticks, and whenever this clock pulses, we get a short pulse out of this torch, goes into the repeater, set on delay 3, which is important here, and then that turns off the torch every 200 ticks, which allows 1 log to go through. And if there's an item in this dropper, a charcoal in the dropper, it's going to get QC powered by that same torch, and then it goes up here if there's room. So the timing for that's also important. There's another repeater here on 3 game ticks of delay, 6 game ticks rather, 3 redstone ticks. So let me turn this on. You can kind of see that delay already. We've got room for 1 fuel, so you'll see an item here. As soon as the torch powers, there's that item. Filled our fuel. Every other item is going to go into our output, which is just represented by this gray wool. This is also a carpet mod feature. If you weren't familiar, hopper counter is true. Really useful for kind of figuring out what the rates are of various things, and also just not dealing with item buildup if you're testing stuff like I am here. So yeah, so our idea there then is that we've got items going in through the top, but since we have everything locked and we're only ever sending in 1 spruce log at a time, whenever it's time to turn this off, so I'll wait for the next item. Okay, say I'm done, I'm going to turn this off. And as soon as this is done, just less than 10 seconds later, the whole thing stops. The furnaces have a chance to cool down, and we're not just waiting for, all 10 stacks or 11 stacks of logs to smelt. So that's kind of a cool design, I think. Yeah, so that is our basic design. Now we can also improve on this even further, though. So I'll show you that next. This little guy who apparently still makes me giggle. I don't know. He's just being him. So this is an example of what a slice might look like. So we've got, jack-o'-lanterns here that kind of help with light updates, which is less of a problem since 1.19 apparently, but I still think it's best practice. The same exact thing, and then instead of having just full stacks in here, we can set it up like this, where we have any sort of item to block the 2nd through 5th slot here, a unique item that's different from the one on top to block 2nd through 5th slots in here. Then we have a stack of spruce logs, a single log, and then we've got some more blockers over here in our fuel input. The furnace just needs 1 charcoal to get initialized. After that, the output's going to go back in, and then it's just going to refill itself until we have a stack here and a stack here. And then the logs up here, this is basically a makeshift item filter. So we're only going to get logs. So in the case that our item stream is sending in sticks and saplings and all that kind of stuff, we would set this up initially like so, and we don't have to worry about that. Now imagine in a case like this where there's just logs coming. So in that case, we don't even need the item up here. We can still put some blockers here and a separate blocker here, and then a single log, a single charcoal, some blockers over here, and this would be good enough for a situation like that. So again, important that these items don't have to be anything in particular as long as they are, well, not the log that you're sorting for, and 2 different items. Doesn't even matter if it's something that's smeltable or not. It's just gonna stay here as long as this thing's operating under normal circumstances. All right, so over here I've got 5 different examples of how we might set this up for use with tree farms of varying rates. So I mentioned the idea of, the locking of the hoppers here, and, basically when you're not using it, it wants to kind of just lock itself. So to that end, we want to use a tree farm that's comfortably over the amount of pull that this thing uses in terms of logs. So all of our surplus, it might not be tons, but we've got plenty to fill up the hoppers when the tree farm's operating, and then the rest just kind of goes off into our storage or cactus. So yeah, so going through, I guess the rates first, and then I'll go through the details here. So what we have here is a 16 furnace module. This would be for a tree farm that is greater than 5,760 logs per hour. And the coal output of this is going to be exactly 7/8 of that input, so 5,040. Next, 32 furnaces. This is going to be 11,520, or comfortably over that for your tree farm. Output would be 10,080 coal per hour, charcoal rather. 48 furnaces. This is going to be 17,280. And, if you've got a tree farm that's faster than that, this would work well. Coal output would be 15,120. This is 96 furnaces. That's going to be 34,560 logs per hour that this thing pulls, and then 1/7 of that is 30,240. Finally, I doubled it again. This is a pretty beefy tree farm here that would supply this one, but I wanted to include this to show the tile ability. And this one's going to be any tree farm that is comfortably over 69,840 logs per hour, and output of this is going to be a cool 61,110. Going through the actual design here, we've got our clock right on the front. Turn that on or off, and then what that does is it basically just powers this line. This repeater is not really necessary, but it's just there for tile ability, so that this unit is the same. When we double it, it just kind of repeats itself. So that's more there for convenience. The next feature that is important here, actually quite important, is that we've got some security features added. So I mentioned that I mentioned the waterfall allocation issue over there. If our tree farm just kind of something happens, like I'm going to go ahead and turn this on. So again, one of the best tree farm designs. So right now there's a little bit of that waterfall allocation problem happening, but as soon as we're filled, or actually it's over a certain threshold, then there's a torch right here that turns off and allows our clock to run. So right now I've got the tree farm explicitly on. I can turn off the coal farm, and that's going to turn itself off. Now we're just sending logs into our output. If we want to turn this back on, now we're generating coal again. But let's say that our tree farm explodes. So, oh no, this could happen overnight if you're AFKing a design that's not 100% reliable, or you're the player, you forgot something and your player gets, bapped by, a hostile mob or something, and then suddenly you're not producing logs. Well, we need some way of detecting that, because otherwise this clock's going to keep going, all of our items are going to drain out, and then we've got a little bit of manual work to do. So what I have here is just kind of a finely tuned set of extra items here and some cake stone. So as soon as this gets to, I want to say it was 56, as soon as it gets down to a certain threshold, then our math operation is going to be verified, and then that torch is going to turn on. So 58. Maybe that was it. No, 57. And in 10 seconds, that's going to turn into 56. And then we essentially override the fact that our levers enabling the farm. So now we've got the farm charcoal module, I guess. It is in a parked state where it's explicitly turned on, but since it's not receiving input, our failsafe kicked in and saved us from having to do a bunch of work. So you can see, especially when we get to the bigger designs here, how that would be beneficial. I would really hate to have built this one in survival and then realize that my tree farm blew up. So I've got to fix my tree farm. Then I also have to go in here and like manually go furnace and hopper spelunking for, 20 minutes. So yeah, showing how this tiles, a couple of things. So I wanted it to be 8 blocks long, and that makes for one, easy math because we have 16 furnaces. But also you can see that it's the exact length of the water stream, so it makes for easy, water and ice stream connections. And it also makes it easy because we don't have to worry about, redstone wire length. So if we expand that to 32, everything's the same over here, but then we've got just enough room to add an ice block for our second water stream, some repeaters. You can just add hoppers to connect those lines. Everything else is the same. 48, same deal. We just expanded these modules twice. Now we can also expand modules this way and have our water streams loop around. This might be good if you're just dealing with like smaller amount of space and you want to make it more of a square shape. And then also if you expand it out this way, you're going to have, eventually you'll run into issues with hopper speed and getting all these items in a single line into your output. So that's an example of how we would expand that. And then finally, I've got this one over here, 194. And this just kind of shows how easy it is to expand, out in that direction. So the water stream's also cool detail since because of the way I'm doing everything, it kind of lines up perfectly. There's just enough 8 blocks to round this corner, and then it's right back in. I don't know. I thought that was pretty neat design. Hopefully this is all useful. If you have any questions about how I'm doing things, feel free to ask when you're taking a look at it. And yeah, for the last part of the video, I wanted to show off the farm in context with, we already mentioned one safety feature, and that one's compulsory, I would say, so just build it like that. But there's some other things we can do to make our whole operations system more safe. All right, so over here I've got an example of how we can incorporate this charcoal farm module in with a tree farm. So I didn't design this one. This was designed by ianxofour, who I have standing here as a bot. And this is a pretty cool design. If you weren't familiar with his stuff, which is probably unlikely that you'd be watching this and also not familiar with him, but in case you aren't, check his stuff out. Lots of cool farm designs. It's a pretty cool design, and it produces comfortably, like actually quite a bit more cherry logs per hour than this would demand. So that's why I'm using it here. And I did make one modification that I'll point out later. So the point in integrating all of this, and I've got it again over here in the world download, I wanted to show some smart systems that we can use to create a more robust setup for safe AFK for long periods of time. So in a case like this, if say our player gets blown up, which shouldn't happen, again, I'll talk about the modification I made here in a minute, but if ianxofour blows up, then suddenly there's not any logs that are being received. So we already talked about that safety feature with our comparator and subtract mode here. But there's some other things that we want to do. So first things first, I'm going to turn on the tree farm to show you a couple of features here. There's our switch. You'll notice that nothing happened. So we saw that there's a line here that gets, this is our signal that we've explicitly turned on the tree farm switch. And then there's some other stuff going on, which I'll point out later, but nothing is happening. Well, that's because our storage system, which is represented by this single double chest, is full. So if this is full, there's really no reason to keep running the tree farm. We can automatically turn it off. But let's say I'm going to remove a couple of stacks. Okay, now we're getting a signal, but the tree farm still isn't running. Well, that's because I've simulated that we ran out of bone meal. So if we've got bone meal, and if our lever's actually explicitly turned on, and if we have enough room in our storage system, then the tree farm can run. So that's kind of one part of this system. But we also have the charcoal farm, which I haven't really mentioned yet. So I'm going to turn off the tree farm. just for a moment. It'll stop. There it goes. So now, let's say that I want to turn on the charcoal farm. Well, it doesn't really make sense to run the charcoal farm without the tree farm also running. So I've used the logic here to make that impossible. So the tree farm switch, since it's not turned on, it's sending power into this block, which means that this torch is off, which means that this one's on, which is locking up our clock mechanism. So I can flick this lever as much as I want. I can't run the coal farm switch while the tree farm's off. So next, I'll turn that on as well. So here, in this case, we're gonna have logs coming in, but you'll notice that our charcoal farm okay to feed sign here, this isn't even lit. The only reason that this is running is that we have room in the log storage. So if I fill that up, our tree farm's going to turn off again, because now we've got a full storage of logs and we have a full storage of charcoal. So this is one more safety feature. You know, when both storages are full, nothing runs. When either storage has room, things can run. But there's one more case that I do want to mention. So imagine that we have our charcoal farm turned off and we've got room in the silo here. So that also shouldn't create a false positive, because we don't want to run the farm when there's room in this silo if the charcoal farm isn't turned on. So that's what this torch is representing. It's basically an and. So you have to have room in the charcoal farm, and the charcoal farm has to be explicitly turned on, and then and only then do you get a signal here. So I can now turn on this farm, and if the tree farm switches off, this doesn't do anything. But, you know, we turn that on, and the coal farm is on. Now things are clear to run, because this torch is turned on. So what we have basically, and maybe I'll put up like some Boolean logic, and this is out of my field of expertise, so if anyone's watching this, if I didn't mention, this also makes apparently a great passive mob farm in a flat world, so keep that in mind. I'm going to put up the Boolean equation that I kind of came up with that describes what all is necessary for the tree farm to run. But yeah, the basic gist of that is that we have to have bone meal, and we have to have the lever for the tree farm on, and we have to have room in our tree farm silo, or there's an or here, the coal farm lever and the silo has room. And only if all of that checks out and gives us a true statement, only then can the tree farm run. So pretty robust system. And then also the last thing, I mentioned that I was going to talk about the modification that I made. Well, that's a problem. So this does not appear to be perfect for cherry logs. I'm really not trying to drag ianxofour through the mud. I'm surprised I haven't seen people comment about, you know, an issue like this, but okay, let's give him room. Oh, he's holding logs. So what happened there? He ran out of bone meal, didn't he? All right, so this is my issue. Okay, so here's an example of using someone else's work and not paying enough attention. Well, I had this lever pulled, which meant that he wasn't getting resupplied with bone meal. So I'm gonna make him maybe drop okay, crisis averted. The actual issue here, though, and I'm pretty confident that this is an issue. In his original design, he used a chain where I have this wall. So I'm going to put the chain back and then kind of nudge him forward a little bit. This has to be some sort of issue where maybe there was a change to how the rays from explosions are calculated. Now he's up against that chain, and I'm going to tick warp this just to show you an example of what might go wrong here. So you can already tell he's taking damage. There we go. So Ian died, unfortunately. What that means is that right now we're in a fault state where the tree farm is explicitly turned on. It has all of the requirements to be on. It still has bone meal left. Everything's good to go except Ian blew up, so now we're not getting any logs. So what's going to happen in this state is once we get down to 56 items, or whatever we configure it to with our, hopper comparator math, once we get down to that level, everything's going to, as a failsafe, lock itself. So we'll watch the log supply interruption emergency standby torch here. There it goes. So kind of an example of why that safety feature is necessary. The rest of this is maybe going a little bit above and beyond, but if you're like me, you tend to, build up a cool farm and then you spend all day working on it, you AFK it overnight, and then you get up the next day and you have to go to work, you're gone for 12 hours, you get back home, you go straight to bed, and then before you know it, you've got a farm that you built and you've just been AFKing it for 100 hours and you wasted a bunch of shulker boxes, basically all of these systems, what we could call control systems design, or control systems logic, we can save ourselves from, disaster in cases like this. So, yeah, I'm going to go ahead and turn the tree farm off. Should immediately have an effect. And again, I'm sure this is just a version dependent thing, so maybe when this was designed, it wasn't necessary, but if you're building this I'm in 1.20.1, put a wall here instead of a chain, and you'll thank me. So, yeah, I guess that is the video. Thank you for watching. I'm going to have, again, like I mentioned, a world download in the description, and if you have any questions about my rat's nest of wiring down there, feel free to ask, and I'm sure that there's, in a lot of cases, better ways of doing that, but the logic itself is sound in terms of the control systems design. So, take a look, let me know what you think, and thank you for watching. Have a great day.